Welcome to our online chemistry class. Our topic is alcohols, phenols and ether. Let us study the next part, that is reactions due to breaking of CO bond in alcohol. So here simply we have to revise the reaction from halogen derivative. In halogen derivative we learn about the action of hydrogen halide, that is HX, on alcohol for preparation of that halogen derivative. Same reaction is here under the heading of reaction with hydrogen halide. So you have to add this hydrogen halide to your alcohol by breaking the CO bond in that alcohol. So there are different types of hydrogen halide: HCl, HBr and HI. In halogen derivative we already discussed the order of reactivity of hydrogen halide is HI is highly reactive than HBr. HBr is more reactive than HCl. The reason behind that is HCl bond is very strong. More amount of energy will be required to break that bond. So it is less reactive because it is more stable. As compared to that, HI bond is weaker, and the reason behind that is the non-comparable size of hydrogen and iodide. So that's why it is that bond HI bond is weaker and it is less reactive. It is more reactive and it is less stable. So now let us consider the order of reactivity of the alcohols toward this hydrogen halide. So tertiary alcohol reacts rapidly with this hydrogen halide. Then secondary alcohol reacts somewhat slower, and primary alcohol even more slower than secondary alcohol. The reason behind is again it is due to the formation of carbocation. So intermediate is carbocation and it is a substitution reaction. So if we observe tertiary alcohol, after breaking of CO bond we get a carbocation, and that carbocation is tertiary carbocation, that is more stable. That's why it is more reactive as compared to tertiary. Secondary is less stable, and the reason is the inductive effect and the hyperconjugation. More number of alkyl groups, 3 alkyl groups are present in tertiary alcohol. Then in case of secondary alcohol there are 2 alkyl groups, and in primary there is only one, or sometimes in case of ethyl alcohol in case of methyl alcohol there is no alkyl group attached to that carbon having OH group. And in case of hyperconjugation, 9 hyperconjugating structures we can observe in case of tertiary alkyl group or tertiary carbocation. That's why it is more stable. So this is about the reactivity. So you can remember these points while learning in the point of multiple choice questions. So HCl reacts only in presence of unhydrogen cell 2. Unhydrogen cell 2 acts as a catalyst. So because it is least reactive, so to increase the reactivity we have to use this catalyst, while there is no requirement of such catalyst when we use HBr and HI. From this also you can easily remember the reactivity order. So when we have to write the primary alcohol is less reactive. So we require unhydrogen cell 2, and then we have to heat the mixture, and what we get, the OH from alcohol and OH from alcohol and H from that HCl, they combine together and they form H2O, and Cl get replaces this OH to use alkyl chloride. So ethyl alcohol gives ethyl chloride. Similarly, you can write N-propyl alcohol gives N-propyl chloride as a product. The reagent is same. Now let us see the reaction. So the remaining reaction that you checked from your halogen derivative, how isopropyl alcohol react with HCl, how. So check here, isopropyl alcohol react with HCl in presence of anhydrous ZnCl2. But as secondary alcohol is the isopropyl alcohol is more reactive as compared to primary alcohol. So here there is no need of heat. So reaction can take place at room temperature, but it is less reactive than tertiary alcohol. So there is a requirement of anhydrous ZnCl2. So again, the hydrogen of HCl and OH from your alcohol, they combine and they form water. Okay. Then as tertiary alcohol is most reactive among these three, so again hydrogen of HCl and OH of your alcohol, they combine to produce product. Okay, and Cl replaces the OH from that alcohol. So as your tertiary alcohol is most reactive among these three, there is no need of catalyst. Only at room temperature these two can react. So it is very important to write the anhydrous ZnCl2 and heat when your alcohol is primary, and when it is secondary there is no need of writing the heat, and in case of tertiary alcohol simply you have to write the room temperature. So this is the importance, keep in mind when you study for CET exam. Okay. Now next is reaction with phosphorus halide, such as phosphorus trihalide PCl3, PBr3, Pi3, and phosphorus penta. Here only pentachloride PCl5 will react. So when we write the reaction of phosphorus trichloride with your ethyl alcohol, then this OH get replaced by this Cl. As in PCl3 there are 3 chlorine atoms, you have to take 3 moles of ethyl alcohol, and again you can write the reaction, this 3 OH from your 3 OH from your alcohol react with 1 phosphorus. Phosphorus is trivalent, so POH thrice or POH thrice or H3PO3, phosphorus acid is your product, and 3 C2H5 react with 3 chlorine to give 3 C2H5Cl. Then when your reaction is with PCl5, as there are 5 chlorine atom, 1 OH get replaced by 1 chlorine, and we get C2H5Cl, and another product is that hydrogen from OH react with Cl to give this Cl, and remaining 3 chlorine react with your phosphorus. So we get POCl3, phosphoryl chloride is the byproduct. Okay. So this is about the reaction with phosphorus halide. Base reagent is SOCl2 thionyl chloride, and for this you have to heat the mixture or reflux, and the byproducts are SO2 and SO3, and they are in gaseous state. They are in gaseous state, so you have to use this as a reagent for preparation of your alkyl chloride, because this is the base reagent. Your HCl and SO2, they are in gas state, so they can easily remove from the mixture and we get a pure C2H5Cl ethyl chloride. This is the base reagent for preparation of alkyl chloride from alcohol, that is thionyl chloride or sulfonyl chloride, that is SOCl2. So this is about the reaction. Now next one is the dehydration of alcohol to alkene. So you have to remove the water from your alcohol and you have to prepare alkene. So for removal of water, you have to use dehydrating agent, and the dehydrating agent is, so can you remember what is the dehydrating agent? So here are some reagent: concentrated sulfuric acid, phosphoric acid. Phosphoric acid is H3PO4 or alumina Al2O3. So they are used to form your alkene and the water is the byproduct. So let us check the reaction here. So here concentrated H2SO4 and heat is the condition. So the OH from alpha carbon and H from beta carbon. So functional group carbon is alpha, next that is beta. So hydrogen is removed from beta carbon, so it is called as beta elimination. So here is the word beta elimination. Reaction is beta elimination, and get, so this bond undergo cleavage and oxygen carrying lone pair of electron, then this carbon hydrogen bond lone pair electron pair towards the carbon carbon, and it form carbon carbon double bond plus water is the byproduct. So what do we get? We get water and your alkene. Here concentrated H2SO4 is the dehydrating agent, and again if you observe the dehydration of alcohol, the order is tertiary. Alcohol is most reactive towards this reaction than secondary. Secondary is more reactive than primary. So if you observe the next one, again your alcohol is primary alcohol, so OH from this alpha carbon and H from this beta carbon get removed. Okay, and we get byproduct water and place a simple double bond between this alpha and beta carbon. So what we get? But1ene as a main product. The common name is butylene. So here again primary alcohol is there, so we require high percentage of H2SO4, 75% H2SO4 and high temperature 430. So now if you observe the next compound, it is butane 2-ol, then in that case OH is attached to secondary type of carbon, so your alcohol is secondary alcohol. Okay, so butanol is primary alcohol. This is primary alcohol. Primary alcohol. Then this is your primary alcohol. Okay, so it is least reactive. High conditions are required as compared to this primary alcohol. This is your secondary alcohol. This is secondary alcohol and it is butane 2-ol. Okay, it is a secondary alcohol. So what is your name? Name is butanediol or isobutylene is the common name of this. Okay. So if you observe this, secondary alcohol is more reactive as compared to primary. So here in case of primary alcohol 75% H2SO4 is used, here 60% used. Temperature is 413 and we require only 373 Kelvin. So that is the main difference. This indicates that secondary alcohol is more reactive. Then we consider the tertiary alcohol. Tertiary alcohol is more reactive as compared to that. So name is, we write the numbering from any side to horizontal way 1 2 3. So on second carbon 2 methyl propane and all these are 3 methyl. So common name is tertiary butyl alcohol. Okay, right, alcohol is tertiary butyl alcohol. Tertiary butyl alcohol. So you must understood the common name of this alkyl group, then you can easily write the reaction. It is very important to know the both the names. Okay, so this tertiary butyl alcohol is react with only 20% H2SO4 and temperature is again decreased to 363 Kelvin. So we get remove. So here again in case of secondary alcohol OH and H get removed from this alpha beta carbon. Okay, then in case of tertiary alcohol again we have to remove H and OH from adjacent carbon. What do we get? We get a product. So what do we get? Double bond is in between alpha and beta carbon, so we get isobutylene as a product. So one important thing that we must familiar with secondary alcohol, we go towards that. So what is that? Here there are 2 beta carbons. Okay, one beta carbon is CH2 carbon, another beta carbon is CH3 carbon. Okay, so if we remove the hydrogen from CH3 beta carbon, then the double bond is in between these 2 carbon. So what do we get? CH double bond CH2. So I'll write the numbering here. This is a carbon number 1, then this is a carbon number 2, then this is a carbon number 3. Okay, if you remove the hydrogen from first carbon, then we get this product. So CH3 becomes CH2, CH double bond, and these remaining things are same. If you remove the hydrogen from third and second carbon, then then the double bond is in between carbon number 2 and carbon number 3. Okay, so we get a major product. So what is major product? So what is the name of these two compound? This one is minor is, if you write the numbering from right side, your double bond is on first carbon and there are only 4 carbon. So 4 carbon alkene is butane, but double bond is there, so ANE replaced by ANE and double bond is on first carbon. So but1E is the product, or it is alpha butylene, and here this compound is double bond is on second carbon, so it is but2. Okay, that is the difference between these two. So now why the word is major here, minor here? So how to decide? So in 11th standard we already learned one rule, and again we revise the same rule in halogen derivative, and the name is Saytzeff rule. So here you already learned the Saytzeff rule related to dehydrogenation of alkyl halide, but now we have to learn the rule related to this in case of dehydration. So our reaction is removal of water, so dehydration. So if there are multiple beta hydrogen, then the preferred product is that alkene which has greater number of alkyl group attached to doubly bonded carbon atom. Now identify the doubly bonded carbon atom in your butane 2 oil. So these carbon number 1 and carbon number 3 are having hydrogens, and they are next to carbon number 2, that is alpha carbon having OH functional group. These are beta carbon, the hydrogen present on that is beta hydrogen. So in case of carbon number 1 there are 3 beta hydrogen. In case of carbon number 3 there are only 2 beta hydrogen. Next is carbon number 4, there is, don't consider the hydrogen on carbon number 4. So you have to, if you remove the hydrogen from that carbon having less number of hydrogen, so here 2 hydrogens are present, but if you remove 1 hydrogen, then that carbon contain only 1 hydrogen. So double bond between carbon number 2 and carbon number 3, and your double bonded carbon contain 1 CH3 on one side, or it is on first carbon of the double bond, and 1 CH3 on second carbon of the double bond. So there are 2 alkyl groups attached to this and double bonded carbon, so it is more substituted. But if you observe, if we remove the hydrogen from first carbon and OH from second, so double bond is on first carbon, so we get butane, and in that second carbon contain one alkyl group, that is C2H5. So, but first carbon does not contain alkyl group, so it is monosubstituted. So according to Saytzeff rule, in case of such a dehydration, preferred product is the alkene that has greater number of alkyl group attached to double bonded carbon. So your but1ene is monosubstituted. It is monosubstituted. Monosubstituted, and but2ene is a disubstituted alkene. So this is the major product because it is more substituted. So I think all of you understood the Saytzeff rule. Again we revise same rule here and in halogen derivatives. So same reaction can be written like this also. The same but2ol, we get but2ene as a, sorry, write down the name of this compound and your product. Okay, this is another example. So again we go to our 12th standard. So here is the reaction, and what is the temperature? Temperature is 373 Kelvin and 60% H2SO4. So that is the mention, you have to mention. So here you have to mention 60%, and temperature is 373. Remember this. Okay, 60% H2SO4, 373 Kelvin, and your major product is but2ene because it is disubstituted. Okay, here we already learned the Saytzeff. Then, do you know the mechanism of such a dehydration reaction? There are 3 steps. So first step is formation of protonated alcohol. So why we use that concentrated H2SO4? Concentrated H2SO4 contain H plus. That H plus react with your OH because there is a lone pair of electron over this oxygen. In alcohol there are 2 lone pair of electron. There are 2 lone pair of electron over this oxygen, and this oxygen, out of that 2 lone pair, 1 lone pair is used to form bond with this H plus, because H plus does not contain electron. The electron from This lone pair is used to form a bond with that H plus. So lone pair is used, that's why positive charge is created, and we get OH2 plus. Oxygen is divalent, but there are 3 bonds here, so plus charge is created, and this is a fast step because they are eager to gain that proton. And in next step there is a formation of carbocation because it is unstable, because oxygen, which is more electronegative atom carrying negative charge, it is unstable. So but here there is a positive charge, so it is unstable, OH2 plus. So it breaks that oxygen carbon bond and the electron goes with oxygen. So carbon carrying positive charge and that oxygen goes with 2 hydrogen as a H2O. So this requires time because again we obtain an unstable species such as carbocation, and then there is a removal of hydrogen from this beta carbon. Okay, first OH is protonated, then OH2 is removed and we get a carbocation, and then hydrogen is removed from beta carbon, so name of the reaction is beta elimination, and the electron pair is used by the first carbon and second carbon to form a double bond. Hydrogen goes without electron, so minus H plus, we get your alkene. So this is our mechanism. So now in case of your previous answer, but2in and but1in, so if you observe the carbocation, when you obtain the major product but2in, the intermediate carbocation is this one. The second carbon contains positive charge and it is a secondary type of carbon atom, so more stable secondary carbocation. But why it is more stable? Because there are 2 alkyl groups attached to this carbon, and there are 2 inductive effects shown by this, and there are total 5 hydrogen directly attached to that beta carbon, so 5 different resulting structures. But if you observe the product but1in, the intermediate is the primary carbocation, and this carbocation contains only one alkyl group, CH2, CH2, CH3. So that whole alkyl group, N-propyl group, considered as alkyl group, so only one plus I effect, and the beta carbon contains 2 hydrogen, so 2 hyperconjugating structures, so it is less stable. Primary is always less stable than secondary, and that's why we get but2in as a major product. Okay, so Saytzeff prefer this mechanism, and the mechanism is removal of water from your alcohol, so it is a mechanism of dehydration of alcohol. So this is about the your dehydration. So can you solve, write and explain the reaction to convert the propane 1-ol 2 into propane 2L. So in 11th standard and in previous reaction we use concentrated H2SO4 as a dehydrating agent. Here Al2O3 means alumina is used. So when primary alcohol is the alcohol, temperature is 623, and if it is secondary alcohol then 523, and if it is a tertiary alcohol then you have to use 423 Kelvin as a temperature. So your propane 1-ol, so temperature is 623. So OH from this carbon first and hydrogen from this beta carbon number 2 is removed, so we get prop1in as a product. But if you have to prepare propane 2-ol, then this prop1in react with concentrated H2SO4, so then we get, instead of this H there is a SO3H group, means total OSO3H group, So propene react with H2SO4 gives isopropylene hydrogen sulfate. So second carbon contain OSO3H group. So that is isopropyl hydrogen sulfate, that is the intermediate. And if you carried out hydrolysis of that, then OH bond undergo cleavage and it becomes OH, and remaining part of OSO3H, that is SO3H, react with your OH gives H2SO4 back. So byproduct is here H2SO4. It is not mentioned, but always you write the balance equation. So it is H2SO4. You forgot to balance your equation. So H2SO4 is a byproduct. Then next is the oxidation reaction. So this is totally new for you. So can you recall what are the various definition of oxidation? So all are familiar with the definition of oxidation that you learn in 10th standard as well as in 11th standard under the heading of redox reaction. So addition of oxygen, this is your old concept of defining the oxidation. So here also you have to add oxygen to your alcohol. So if we add oxygen to your alcohol, then what happens? So on reaction with this oxidizing agent, all your primary alcohol, secondary alcohol, they undergo removal of hydrogen. So the name of the reaction is dehydrogenation. So this is another definition of your oxidation: addition of oxygen or removal of hydrogen, that is dehydrogenation means oxidation. So if we remove the hydrogen from your alcohol, so hydrogen from the carbon having OH, that is alpha carbon, and hydrogen from OH group, they get removed. So they remove as a H2O, H2 with this oxygen. They remove hydrogen with this oxygen. Okay, and it gives byproduct as H2O. So don't forget, reactions are not balanced in your book, but you have to balance these reactions while writing in your notes as well as exam. Okay. So this is the byproduct. So for example, primary, so we get this product. So example is, so write down R group as a CH3. So CH3 CH single bond OH CH3, that means isopropyl alcohol. So I write CH3 twice CHOH, it is same. React with, so OH is on secondary carbon, so it is a secondary alcohol. React with chromium, chromic trioxide, and there is a removal of hydrogen with your oxygen, and we get a water as a byproduct. So when we remove the hydrogen from carbon and oxygen, we break that bond. So we have to place a double bond between carbon and oxygen, because to maintain the valency of carbon as a 4 and oxygen as a 2. So we get double bond between two carbon. What we get? We get C double bond O functional group compound, and that compounds are ketone. So if we take isopropyl alcohol, we get CH3 CO CH3. It is acetone. Okay. And if we take primary alcohol, which on oxidation with this same reagent CrO3, it forms aldehyde, but the better reagent is PCC, pyridium chlorochromate. And again same is the reaction, the hydrogen from OH and one hydrogen from your alpha carbon, not both the hydrogen, only one hydrogen is removed, that remove as a water. And don't forget to write the byproduct. Okay, so if R is equal to CH3, here we get CH3CHO. So your compound primary alcohol is CH3CH2H ethyl alcohol, and product is CH3CHO acetaldehyde. So what is the IUPAC name of ethyl alcohol? Ethanol. 2 carbon ethane, replace E by OL, and here 2 carbon aldehyde, 2 carbon alkane ethane, replace E by Al because it is aldehyde. Now how will you write the IUPAC name of isopropyl alcohol? Here 3 carbons compound is present, so 3 carbon propane, OH group is on second carbon, propane 2-ol or 2-propanol, and your ketone is, the alkyl groups are methyl, they are same, so di, because they are 2 in number, dimethyl ketone is the IUPAC name of acetone, common name of acetone. Notice the IUPAC name, 3 carbon compound is your ketone, so 3 carbon is propane, then replace the word E by ONE because it is a ketone, so, and your C double bond is on second carbon, so prop 2-ol is the IUPAC name. Now there are different another oxidizing agent such as potassium permanganate, KMnO4, nitric acid that you already know, HNO3, then potassium dichromate, K2Cr2O7, but you have to add dilute H2SO4. So these are the different reagents, they also generate the oxygen, and that oxygen is used for oxidation similar to your CrO3 and PCC. So if these reagents are used for oxidation of primary alcohol, then first we get aldehyde, no doubt, but that aldehyde can also react with this reagent, and we can't get only aldehyde, that aldehyde is converted into acid. So when you have to obtain only aldehyde, then don't prefer these reagents, but only prefer PCC as a reagent. So let us see the reaction, what happens if we use your any reagent out of that. So here we use K2Cr2O7 in presence of dilute H2SO4 that generate the oxygen that react with the 2 hydrogen from carbon and oxygen, so it removes the water and we get acetaldehyde, and then that acetaldehyde react with again to your compound acetaldehyde, react with K2Cr2O7 in presence of dilute H2SO4, and again it removes the water, the hydrogen instead of removing water, simply you have to add oxygen to C double bond O carbon, so we get C double bond O OH. Okay, so functional group is dash COH. So your name of the compound is, what is the name? 2 carbon acid. According to common name system, the name is lactic acid. Okay, and how many carbon in your compound? According to APE6, when you write the name, ethane is the parent alkane. Replace E by OIC acid. So your compound is ethanoic acid. So this is your compound. According to common name, acetic acid the name, and according to IUPAC, ethanoic acid is the name. Okay. Then this is the general representation. You can use KMnO4 HNO3 as a alternative oxidizing agent. So you can use anyone out of that. But tertiary alcohols are difficult to undergo oxidation because if you observe primary alcohol, there is a removable hydrogen on primary carbon. In case of secondary alcohol also, if you observe this isopropyl alcohol, there is one hydrogen, but in case of tertiary alcohol, there is no such a hydrogen on that alpha carbon. Okay, so tertiary alcohol does not give reaction with the normal oxidizing agent such as the previous reagent. So we require is some strong oxidizing agent at higher temperature, but we can't get aldehyde and ketone, we get your alkene. Okay, so let us see the reaction. So reaction is tertiary alcohol react with copper in presence of 573 Kelvin temperature. So there is a removal of water, OH from this and hydrogen from your beta carbon is removed, and there is a double bond. So dehydration is the reaction. So you can write byproduct as water. Water. So don't forget to write the byproduct. Always you have to remember the byproduct. Okay. So you get isobutylene, or you can write the IUPAC name of same compound. This reagent can also react with primary alcohol and secondary alcohol. So again same is the result. The alcohol gives the acetaldehyde, isopropyl alcohol gives dimethyl ketone. Then one question is remain, and what is that? An organic compound gives hydrogen on reaction with sodium metal. It forms an aldehyde having molecular formula C2H4O. On oxidation with pyridium chlorochromate PCC, name the compound and give the equation. So unknown compound is there. So as it gives the hydrogen with sodium metal, definitely it is alcohol. So that we already learned, it is not a phenol because sodium is most reactive, and we get your sodium alkoxide. Here two carbons are present, so your compound is 2 carbon alcohol, so ethanol. What is the reaction? Ethanol react with sodium metal, it gives sodium methoxide plus hydrogen, and that on oxidation with pyridium chlorochromate gives 2 carbon aldehyde. Primary alcohol is the ethyl alcohol, it gives acetaldehyde as a product with water. So this is your answer of the question. Thank you.